Hey everyone, today is 5th August 2024 and we're going to solve the problem of the day. Just kth distinct string in an array. So I'll directly explain the problem from this example since the problem here is poorly worded. So as you can see here, we're given an array of strings and we want to return the kth distinct string. So first, what is a distinct string? If you look at a string and you don't find that string in the remaining array, then it's a distinct string. So like the D here, you don't find it in the remaining array. So D only occur once, it's a distinct string. B is not distinct since B can be found again. C is also not distinct, but A is distinct. So this is the definition of a distinct string. Now, how will we solve the problem? So first, we need to notice that whichever string is frequency is 1 is her distinct string. So first we'll form our map of frequencies. So we'll iterate over this array. So first D, so I'll increment the frequency of D to 1. Then we go to B, I'll increment the frequency of B to 1. Then we go to C and I'll increment the frequency by 1. Then we go again to B, sorry, then we go again to B. So let's increment, make it 2. Then we go to C, make it 2. And finally we go to A and we make it 1. So now we have the frequency of all the elements. Now we have to do another pass to find the kth distinct element because the kth position of distinct element is determined in the order which the string is array is given. So as you can see here, these strings are considered in order in which they appear in the array. So that's what the order is. So what we'll do is we'll keep the track of which distinct element are we currently seeing. So it will say the ith distinct element will tell us that this element, if it's distinct, it's the ith element to be distinct. So let's go over this. So we have 0 distinct elements for now. So for D, we'll check in the hash map. So hash map lookup is constant time complexity, so it's pretty efficient. So we find that frequency is 1. So we are seeing a first distinct element. So we'll increment it. Then we go to B. B's frequency is not 1. So we'll move on. C. His frequency is also not 1. Again B. Again C. And when we come to A, we see its frequency is 1. So we see that this is the second distinct element. Now, each time we increment this, we'll compare it to K. If it is equal, we'll return wherever the pointer is at. So we'll return A in this case. So output will be A. Suppose if the K was 3, then this pointer will go out of bounds and we'll return an empty string since the question demands us of that. So let's code this solution. So first what we need to do, let's see. Okay, we need to iterate over the array and keep the map of frequency. So I'll create a map. Create an unordered map. Since in an unordered map, the insertion and lookup is constant time only. So map will be from, sorry, string to int, string to int, and it will be called frequency. Then I'll go for string s in array frequency of s plus plus. So we got the frequency. Now we'll again iterate over s, but this time we'll do it like this: less than array dot size I plus plus, and we'll note here that this is the I distinct string, which is initially 0. Now, if frequency, I don't think we have to even do that yet. We can just directly do string s in array. Frequency of s is 1, which means it is a distinct string. We can say that I distinct string plus plus, which is to say that we have seen another distinct string. Now we'll check if this ith distinct string, which means that have we seen k distinct strings, and is this the kth distinct string? If that's the case, we will return s, and if it never becomes true, we will just return the empty string. Let's run the problem. Meanwhile, it's running. I'll just tell you the time frequency and space complexity. The time complexity of this will be big of n, since we are iterating over the array two times, which is 2n is just n asymptotically. And space complexity will also be n, since we are taking n space to store this unordered map. So yeah, let's submit this. And yeah, it beats 73%, so it's pretty efficient. Thank you.